It's Mark. With a usable physical 2 to the 4 cube in hand, one of the things that occurred to me was match up colors using some custom colors on MC4D and try to compare moves back and forth. I found this so useful that I thought I would share it with you. The simplest set of moves that I'm going to consider here are all the moves that use just the right or left halves of the cube. You know, R O twist, R F prime twist, etc. And also the half turns of a slab of the physical cube. The UO2 twist, UO2, FO2. And it'll be interesting to go to the MC4D puzzle, FO2, and make sure that every corner of the puzzle really has the correct piece in it and the correct orientation. So in the right front up in position, I have an orange, yellow, green, purple piece. Right front up in, orange, green, yellow, purple in the comparable positions. If we do that for all of the corners, we can be confident that this FO2 twist is the same operation on this version of the puzzle as this FO2 twist is on this version, much increasing our confidence that that we're talking about the same puzzle. Where I'm going with this is to define a set of useful moves on the physical puzzle, make sure each of them has a macro that can do the same thing on the virtual puzzle, and make sure that every move on the virtual puzzle has a move sequence, a single move or a move sequence on the physical puzzle. I'm only considering the right angle moves on MC4D, not the diagonal ones, because I'm confident enough that that we can reach all the states with just the right angle moves, and I don't want to deal with the confusion. Given that, we will hopefully realize that that these puzzles are the same, have all the same states. They have slightly different move sets, but they're translatable one to the other, and we can learn a bunch about each puzzle from the other one. That will be very satisfying. One thing you'll notice, though, is these moves that I have defined so far, the 4 slab moves, FO2, BO2, UO2, DO2, and the right and left face moves leave orange and red on these outer corners, the combination of the left and right faces of the cube. Clearly we're still in a subset of that space until we can get these corners off of there. Or another way of looking at it is there are some 90-degree twists that we're unable to achieve just with that set of moves. But Melinda found a nifty sequence that that does that full cube rotation. I found a second sequence. Melinda's I made a version of that's exactly corresponding to the front out rotation, and I've nicknamed it faux row, and mine is foo row, and I will describe those in another video. With that in hand, we'll be able to take every one-click move on MC4D and either achieve it with a single natural move on the physical puzzle, or we can replicate it by doing a full cube rotation where at least one of the axes that stays fixed ends up on the right or the left face. Then we can do all the twists that involve the right and left faces, and then transform it back. And that will get us our equivalents, although it won't necessarily get us our fun to solve physical puzzle. Then defining the move set that's fun to use will be another good project once we've satisfied ourselves that there's a useful and interesting equivalence between them. On to those key rotations, faux row and foo row.